graph rational functions. So let's pull a lot of our knowledge together and use symmetry, the y-intercept, the x-intercept or ceps, and asymptotes or holes to sketch the graph of a rational function. How are we going to do it? Well, we're going to use the graph to see if there's any symmetry. We're going to find the y-intercept by computing f of 0. We're going to find the x-intercept or intercepts, and we do this by setting the numerator equal to 0. The only way a fraction is equal to 0 is if the numerator is equal to 0. We're going to find the vertical asymptotes, or holes if it has any. We're going to find the horizontal asymptote if it has one. And then we're going to sketch what we know and then plot points between and beyond each x-intercept and vertical asymptote to complete the picture. Okay, so let's use this six-step strategy to sketch the graph of the rational function 2x minus 1 over x minus 1. Okay, first things first. We're just going to use to see if we have any symmetry with our graph. So clear these out. Does our graph show any symmetry? 2x minus 1 over x minus 1. And let's see if we have any symmetry, any y-axis symmetry or any origin symmetry. And the answer is no. The graph does not show any origin symmetry or y-axis symmetry. So 1, symmetry, we have none. Okay, 2, how about the y-intercept? Find the y-intercept. The y-intercept is when x equals 0. And I guess I'll underline these to highlight them a little bit. So we know that our function is f of x is equal to 2x minus 1 over x minus 1. When x is 0, we have 2 times 0 minus 1 over 0 minus 1, and we have 1. So we have a y-intercept at 0, 1. 3, how about x-intercepts or x-intercepts? Okay, well, this is when, let me get my paper turned over. I did not get my paper turned over. There we go. This is when y is 0. So we want to have our function, which is 2x minus 1 over x minus 1. When is that 0? Well, the only, whoops, I'm sorry, I lost you there. The only way a fraction is equal to 0 is if the numerator is equal to 0. So let's take a look at when 2x minus 1 equals 0. Add 1 to both sides, 2x equals 1. So x equals a half. So we have an x-intercept at 1/2 0. Okay? An x-intercept at 1/2 0. I forgot to raise my sheet again. I gotta get focused better. Okay, step 4 is find vertical asymptotes. Okay, let's get my sheet in a good place here. Step 4, we're looking for vertical asymptotes. asymptotes or holes. Okay, so here is our function. F of x is equal to 2x minus 1 over x minus 1. Notice we have something going on at x equals 1, which is not in domain. The denominator cannot be 0, so x equals 1 is not in the domain. Is it a vertical asymptote or a hole? Well, both of these are as factored as possible, and since there's not since x minus 1 is also not a factor in the numerator, x equals 1 is a vertical asymptote. So x minus 1 is not also a factor in the numerator. Okay, so x equals 1 is a vertical asymptote. We have no holes. We only have the one, what they call discontinuity. So there are no holes. Okay, step 5. How about horizontal asymptotes? Horizontal asymptote, because we can only have one, max of 1. Let's again look at our function. F of x is equal to 2x minus 1 over x minus 1. Are my degrees equal? They are. My degrees are 1 and 1. So I'm set. I look at the coefficients, and I have 2 over 1, which means y equals 2 is a horizontal asymptote. So I have the same leading degree. Both of these are degree 1, which means my coefficients are prepared immediately to give me my horizontal asymptote if I have one. Okay, step 6, let's pull it all together. Okay, pick some points as necessary. Pick some points and sketch. Okay, so what do I know? All right, I'll draw kind of a big graph. I got lots of space here. There we go. Now you can really see it. Okay, so I know I have a horizontal asymptote at y equals 2. So there's my horizontal asymptote. And that came from number 5. I have a vertical asymptote at x equals 1. As a reminder, the graph cannot cross a vertical asymptote. It can cross a horizontal asymptote. Let me take a look at the other side of my paper. I have a y-intercept at 1 and an x-intercept at 1/2. Okay, so I have a y-intercept at 1 and an x-intercept at 1/2. Okay, so that's what I have so far. So we need to kind of pick some points around either side. So I'll make an xy or f of x table. And I'm going to pick some points over here to the left. I'll pick -2 and -1. And we know, of course, that f of x equals 2x minus 1 over x minus 1. I'll pick a point between this intercept and the asymptote. That would be, why not 3/4, because that's 1/2. And I'll pick a couple of points over here to the right of the asymptote. I'll pick 2 and 3. Well, I'm going to run -2 into the function, and out comes 5/3. So at -2, 5/3 is a little bit less than 2. It's about there. I'll run -1 into the function, and out comes 3/2, which is here. So it looks like that's the graph on the left side of the vertical asymptote. I'll run 2 into the function, and out comes 3. Whoops, I forgot. Oh, excuse me, I forgot to do 3/4. 3/4 gave me a -2. That's what I forgot to do. That's down here. Sorry about that. I forgot to give you to apply 3/4. So now that really shows how that looks. Let's put 2 into the function, and out comes a 3, and that's up here. And let's put 3 into the function, and out comes 7/3, which is less than 3. That's 2 1/3. And so that, if I put 3 in, That is down, excuse me, I made a mistake. This is 4. I put 4 in. I get 7/3. Couple mistakes. Hopefully you can follow along with me. I put 4 in and I get here. So it looks like what's happening is to the right of the asymptote, that's going on right there. So there's my sketch. No symmetry. Intercept, intercept. Vertical asymptote, horizontal asymptote, and I just chose a variety of points on either side of the asymptote and around the intercepts to kind of get a sense of what's happening with my graph. Now we've already seen it, so we know how it's going to turn out, so I won't check it again for you. Let's do one more example quickly. Just a moment. Okay, this has a little bit more going on, I believe. Yes, okay. First off, let's check symmetry. And I can already tell you, let's see what the symmetry looks like in this one. Does it have any symmetry? This is 3x squared over x squared minus 4. So, y equals, where's my fraction bar? 3x squared over x squared minus 4. I'll make sure I'm in the standard window. Do I have any symmetry? I actually do have symmetry. You can see it's symmetrical with respect to the y-axis. That can help us to draw it. Of course, we can see it. That can help us to draw it. So, symmetry, yes. I have y-axis symmetry. 2, how about a y-intercept? You know, when x is equal to 0. Well, when x is equal to 0, I have 0. Whoops, you can't see that. When x is equal to 0, I have 0 divided by negative 4. 0 divided by negative 4 is 0. So when x is equal to 0, y is equal to negative 4. That's my y-intercept. Excuse me. Y is equal to 0. Making a variety of mistakes in this video, aren't I? Okay, yes, if I put 0 in for x, I get 0 divided by negative 4, and that is 0. Okay, sorry about that. Couple slip-ups. Couple of slip-ups. Can't even say slip-up. How about my x-intercept? And this is when y is equal to 0. And let's remind ourselves, the function is f of x is equal to a fraction. It's a rational function. 3x squared over x squared minus 4. And the only way that y is 0 is if the numerator is 0. So when is 3x squared equal to 0? Well, I'll divide both sides by 3. I'll take the square root, and it turns out that x is equal to 0. So I have a y-intercept at 0. I have an x-intercept at 0. So the origin is my x-intercept and my y-intercept. Okay, let's take a look for vertical asymptotes and holes. Okay, that requires that I do some factoring as necessary. So let's rewrite the function. This is 3x squared over x squared minus 4. Well, the numerator factors as 3 times x, that's factored. The denominator is a difference of squares, and it factors as x minus 2 times x plus 2. So what do I know? I know that 2 and negative 2 are not in the domain. Are they vertical asymptotes, or are they holes, or do I have one of each? Well, you'll notice that the x minus 2 factor is not in the numerator. The x plus 2 factor is also not in the numerator. So both x equals 2 and x equals -2 are vertical asymptotes. They are not wholes because there is not a common factor in the numerator. Let's check for a horizontal asymptote, number 5. Horizontal asymptote. Let's rewrite our function down here. Okay. Do I have the same leading degrees? Yes, they're both squares. So I'm fine. I look at the coefficients to get my horizontal asymptote, and I have 3/1, which tells me y equals 3 is a horizontal asymptote. That was easy. Now let's sketch. Of course, we've already seen it, but we're now going to sketch it. Okay, I'm going to draw a pretty big graph because I know how this turns out. Okay, what do I know? I have y-axis symmetry. I know that. I know that I have x-intercept and y-intercept at the origin. I know that 2 and -2 are both vertical asymptotes. Okay, that's good. And I know that I have a horizontal asymptote at 3. Okay, well that's pretty neat, except for I need more information than this. Obviously this, I'm going to be bound in here somehow. I can't get across those two, but I have no idea what's happening to the left and to the right. So let's pick some points. I'll make a table of values here. This is my x, and this is my f of x is equal to 3x squared over x squared minus 4. And let's see here. Okay, so I'll go to the left here. I'll put in a -3. I'll go between these two with a -1. I'll go between these two with a +1. And I will go to the right of this vertical asymptote with a +3. If I put -3 into the function, out comes 27/5, which is 5 and something. That's up here someplace. And since this is a vertical asymptote and that's a vertical asymptote, that's a horizontal asymptote, I'm going to guess it does like that. Okay? It's bounded below and it's bounded to the right. Let's look in here. -1 goes into the function, out comes -1, so that's down here-ish. +1 goes into the function and also -1 comes out, and so that's down here. And so I'm going to guess that this is what's happening in between the two vertical asymptotes. Now I know I have y-axis symmetry, so I know that I have same on both sides, and that obviously is quite clear here. If we put 3 in to here, we indeed get 27/5, the same answer as we got up here, which means 3 goes in and we're back over here. And so you can again see there's your symmetry with that piece on that side of the y-axis. So there is a sketch of your graph using symmetry, y-intercept, x-intercept, asymptotes or wholes, as well as horizontal asymptotes.